Howdy Huskies, today we're going to go ahead and solve exponential equations using our logarithms. So in review, our exponential equation is one where we go ahead and we have our variable as the exponent, and seeing how that's where most of our x's live, we're going to go ahead and solve that. Now in the past we've done this one where we've had an x on both sides and we had to do the same base, and we'll come back to that. It's a good review. But for this part we're really going to focus on an exponential equation where you only have one variable term. That's going to be the start of what we have on this first one, is one variable term. So we can see it's 6 to the x. And so because it's to the x, most of us want to go ahead and divide both sides by 6. But that's not what we're going to be able to do here because it's in an exponent. So I like to think of this as it's in a tree. Draw my fun little tree here. So that's x in a tree, and it can't be come down by dividing. We're going to have to make it come down by dividing by, or excuse me, by turning it into a log. So the idea is step number one is you're going to isolate the variable term, and we'll see more about that here in the next couple of ones. Then step two, a couple of teachers have some different ways of doing this, so check with your teacher on the way they like the best. But since I'm doing the video and we have to pick one, the idea is you're going to convert to log form. And then step number 3, my friends, is you're going to solve for x. There might be some more solving to do. Okay. Now, ladies and gentlemen, boys and girls, we're going to get some decimals in this one, so make sure you have your calculator handy. So again, this x is up in a tree. We need to convert it to logs. So this is my base. So remember, the base is going to stay our base, so it's log base 6, and then these two are going to swap sides. Of 27 is equal to x. Well, now our x is isolated, and so we have to use our change of base rules to go ahead and solve this. So we're going to go ahead and say log of 27 divided by the log of 6 is what we're going to get our answer for x is. So we get our calculator out. So we'll do log, whoop, that's not the log button, log 27 divided by, and then our log of 6. And then we're going to get 1.83. And I like to go ahead and put, 839. I like to round to that third decimal point for me. And then, of course, you can check your answer by plugging it back in to make sure it works. And it's going to be an approximation, so it's going to be close. But if I say take 6 and I go to that decimal of 1, whoops, did the wrong button, 1.839, we're going to get super close to, I'd say that's pretty much 27. So we have a little bit of a rounding error, but I'd say we're pretty close, and so that's a way to check our answer. So let's do number 4, going a little bit out of order because it's the same sort of concept to make sure we're good. So again, this x is in a tree, and we need to get that tree by itself. So we're going to go ahead and convert it. So log base 5 of 72 is equal to x, because this is my base, so it's still the base. And then the other two, I like to say switch place or switch sides, however you want to convert it. Everybody's got their own fun saying. So we're going to go ahead and use our common base rule. So log 72 divided by log 5, and we put that in the calculator. Log 72 divided by log 5, and we get our answer. So x is going to be 2.657. So that's what we're going to do when we have, my friends, just 5 to a power, or in the previous one, 6 to a power equals a number. Now, notice we really haven't done this isolating the variable term, and that's what our next couple are going to do. We really need to get that variable term by itself. So what do I mean by variable term? So let's investigate. Variable term is going to be that whole piece where that x is in the exponent. So it would be like that one or this one right here. And I should really clarify that that is just this part here. And then last but not least, it's just that part here. So whatever basically has the exponent, we need to get that by itself first. That's that isolating. So here, because it's a minus 6, we're going to do the opposite. So we'll plus 6 to both sides. So we get 8 to the 3x plus 2 is equal to 11. Okay, so now we're all good. This is isolated. Okay, it's the only thing on its own side. So now we're going to convert. So I like to put parentheses around anything with a plus sign, so I know that it's one piece. So remember, this is the base of our exponent, so it's the base of our log, so log base 8. And then these other two are going to swap, so this is 11, and then 3x plus 2. Okay, and that was in parentheses. So we'll go ahead and say, all right, what is this? Log 11 over log 8, because we need to know what decimal that's going to be. And we already calculated that beforehand, so it's 153 is equal to 3x plus 2. So now we're just going to solve for x, because remember, the last part here was just continue to solve, sorry. So right here, step 3 was continue to solve here for x. So we're going to continue to solve for x. So we're going to minus 2, okay? And then eventually we're going to divide by 3. And so x is going to be equal to a negative 0.282. That's our answer for that one. Nice and easy peasy lemon squeezy. So again, the key is getting that variable term by itself. So we said variable term, but that variable term does not include this a value that's in front of it. It is just your base, which in this case is the e, and then your exponent. All this is going to be our exponent term, okay? That 6 is going to be an a value, if you remember from our graphing. So we're going to go ahead and move that around, okay? So let's go ahead and minus 8 first. You're always going to do the adding and subtracting first. So 6e to the 0.25x is equal to 12. And again, I want just this e by itself. So I'm going to divide both sides by 6. And so these 6's will cancel. So what's left is e to the 0.25x is equal to 2. Now, since this is the only thing left on that side, we're going to go ahead and convert. So in this case, my base is e, so I have log base e. And then we're going to do our switcheroo. So of 2 is equal to 0.25x. Now, anytime we have a log base e, we're going to rewrite that as the natural log of 2 is equal to 0.25x. And so we can get our calculator out and we see that right here is the ln button. So we got ln of 2. Oh, did I not close my parentheses? Oh, I didn't put a number in, that's why. So I'm going to get 0.693 is equal to 0.25x. Divide both sides by 0.25. And our answer is going to be 2.773 when you put that into the calculator. And again, you can check this by plugging it back in and making sure your answer gets 20 or pretty gosh darn close to 20. Alrighty, ladies and gentlemen, this is going to give you kind of a fun answer, but I want you to pause and give it a try. So hit pause and try number 5 and see what you get. Welcome back. You should have gotten 0. So if you got 0, go ahead and skip ahead. But if not, let's investigate why. So minus 2, because we're isolating. So I get 3e to the 0.5x is equal to 3. And I just want that e to be by itself. We're going to divide both sides by 3. So e to the 0.5x is equal to 1. Then I'm like, okay, so we're going to convert. So log base e, and these will flip-flop, of 1 is equal to 0.5x. So that's going to give us the ln, because log base e is ln of 1, is 0.5x. And when we put this into our calculator, we're going to go ahead and get 0, which is, it makes sense. So remember, the power or the idea of exponents is if we say, hey, how do you go from e to 1 using exponents? Well, anything to the 0 powered is 1. So that's 0 is equal to 0.5x. So then when I divide, I get x is equal to 0. And it's totally cool to have 0 in there as an answer. Cool? So that's the new stuff for today. We're going to go ahead and do our one of our properties of equality, just as a good reminder. I'm going to erase so we can focus on the next part. So notice here, if they have the same base, that's the kicker. If they have the same base, that means that the exponents are equal to each other. So we can see that I have this x and that y. Okay, but again, the kicker is that they have to have that same base first. So in an example, if this is same base, we call that same base smiley face. Then we can take our exponents and set them equal to each other. Easy peasy. So let's do one of those. I should say we just did one of those. So here they don't have the same base. So we're going to need to make sure that they are the same base. So if I look at that 64, 8 to the 1 is 8. 8 squared is 64, but none of those make 16. So let's try something else. Let's try another number. So let's go 4. 4 to the 1 is 4. 4 squared is 16. 4 cubed is 64. And then 4 to the 4 is 256. Well, I have my 64, and I have my 16. Okay, so what we're going to do is we're going to take their corresponding powers, and we're going to rewrite. So that 64 is now going to be a 4 cubed. And then you had an x already there, so I like to put that x in parentheses. And for the 16, that was a 4 squared, but then I had an x plus 1 that was already there. So it puts in parentheses. So our exponents go in parentheses. So that's what we did here and here. So now that we have the same base, because they're both 4s, so same base, smiley face, so then we're going to go ahead and have 3 times x is equal to 2 times x plus 1. Doing a little bit distributing here, and we're going to get 3x is equal to 2x plus 2. Subtract that 2x over to get our like terms together, and I'm going to get x is equal to 2. Okay? Alrighty, so one last one here, sports fans. Why don't you give it a shot? Welcome back. So this is 3 squared, because that's the same thing as 9, and then I have a 2x that's already there, and so that's in parentheses. So then 3x minus 3. So again, the goal is that we have the same base, and since we do, we have a smiley face. So 7x minus 3 is equal to 4x. And that's just 2 times 2x. So we're going to go ahead and get a 7. Excuse me. Well, I'm going to bring that over and get 3x minus 3 is equal to 0. So 3x is equal to 3. So x is going to be 1. Alrighty. So ladies and gentlemen, I want you to read this word problem first and then come back. Welcome back. So we have this formula. It's kind of a saucy formula, but it's a cool one. And so we got to make sure we know all the pieces. So we have the initial temperature. Okay. So the initial temperature for us as a human, we're going to go ahead and call that 98.6. I know it's not perfect for everybody, but we'll call it good. All right, then we have the T sub R. That's going to be the surrounding temperature or the temperature of the room. I like to put the R for room. So in this case, the temperature of the room is going to be 73 degrees. Okay, and we have that in 2 different spots. We got to make sure that we put that in on our 2 different spots. Okay, now the T is its current temperature. So the current temperature when we found the body is 86 degrees. And last but not least, the thing we need to do is that R, which is hiding up there at the top. And everything's got a cooling constant that's a little bit different. So we're just going to give you that cooling constant. So let's write our formula. So the temperature currently is the initial temperature minus the temperature of the room. E, as in our 2.718, to the negative RT, rate times time, plus the temperature of our room. Okay, so let's plug it in our values. So I get 86 is equal to 98.6 minus 73 e to the negative 0.0033. And we're solving for when, so our time is going to be t. And then we're going to say plus temperature of the room, which is 73. So just as we did in the previous example, I need to get this by itself. This is my variable term. And so everything else has got to move. So the first thing we're going to do is move this to that side, so minus 73. So I'm going to go ahead and get 13, and then I'll do this math right here because I have a chance to do it. It's going to be 25.6 e to the negative 0.0033 t. So again, I'm trying to get this part by itself. So we're going to divide both sides by that 25.6. So it'll cancel out right here, and all I'm going to have left is e to the negative 0.0033 t. And then this is going to be 0.508. Alrighty, so now we have just our variable term, and our variable's in the exponent, so we need to convert. So I have a base of e, so we'll go ahead and have log base e of 0.508 is equal to, I should move this over, negative 0.0033 t, base e of 0.508. All right, log base e, remember that's just ln. So the ln of 0.508. And then we're going to use that ln button in our calculator to find out what that is. So ln of 0.508. Boom shakalaka. Gives us a negative, and that's going to be okay. Don't worry about it. It's all going to be fine in the end. So negative 0.667 is equal to a negative 0.0033 t. And remember, our goal now is to isolate our t, so we'll divide both sides. Told you it would be okay to divide because two negatives are going to make a positive. So these will cancel, and this is definitely put it in the calculator and let it do its thing. T is going to be 205.23 minutes. All right, sports fans, that's it for today. We'll see you next time.